Hi, everybody. Welcome. My name is Marissa, and I'm a technical marketing specialist here at Cloudinary. Some things that I do on the day-to-day job are handle product launches, our go-to-market strategy. I cover competitive analyses, demos, feature videos, and all of the likes. And today I am here with my colleague Akshay.
Hey, everyone. My name is Akshay Ranganad. I'm a senior solution architect at Cloudinary. I work with customers on migrating their assets, bringing them on board, designing workflows, and helping them implement anything that just makes them feel good about us and goes beyond our standard product offering. And we're glad that you're here today with our session.
Yes. So let's go ahead and look at the slides. Okay, so hopefully you're in the right place. Today we'll be covering faster media equals faster websites. So next slide, please. And since you've already heard about us, let's move to the next slide. Perfect. So the objective for today's session is hopefully at the end, you should be able to articulate the different core Web Vital metrics, understand the tools to measure it, and relate the audit findings from Google Lighthouse to specific media optimization techniques. Next slide, please. So with that, the agenda for today is going to be, I'll be covering web performance presentation. And in that, we will talk about the core Web Vitals, what they are, why you should care about them. Then we'll go to tools, so how you can measure core Web Vitals. And then we'll talk about web performance's best practices and how you can put them into action. And then we will have Akshay covering optimizing an e-commerce landing page. And in that, he will talk about measuring baseline performance, implementing optimizations, and measuring optimized performances. So next slide, please. So we wanted to recognize and just kind of call out from the beginning that there are a ton of typical pain points when it comes to media. And a lot of them are what you see here. They have to do with image resizing and formatting, video manipulation and transcoding, creating responsive images, art directions such as cropping at scale, and hard coding image and video dimensions, and having a lack of SDKs. So while there are all of these typical pain points, today we are just going to be solely focusing on image resizing and formatting. So next slide, please. Next slide, please. Perfect. So we are going to be talking about core Web Vitals. So Web Vitals is an initiative by Google to provide unified guidance for quality signals that are deemed essential to delivering a great user experience on the web, as that is key to the long-term success of any website. So whether you're a developer, marketer, or business owner, Web Vitals can help you quantify the experience of your site and identify opportunities as to where you can improve. So next slide, please. So before I get into what these core Web Vitals are, let's quickly discuss why you should care about them. So as of June 2021, core Web Vitals began to roll out and have a direct effect on your page rankings, as Google has made page experience an official Google ranking factor as a way to deliver great user experiences. So page experience will be a combination of factors that Google considers important for user experience, and that includes HTTPS, mobile friendliness, lack of interstitial pop-ups, safe browsing, such as not having malware on your page, and core Web Vitals. And as you can see here, Google's own studies show that for pages that meet these thresholds of core Web Vitals, visitors are 24% less likely to abandon the site. So not only will core Web Vitals help increase your page rank and help you deliver a positive user experience, but in doing so, you will likely decrease site abandonment. So with that being said, let's talk about what the core Web Vitals are. So next slide, please. So each of the core Web Vitals represents a distinct facet of the user experience, is measurable, and reflects the real-world experience of a user-centric outcome. The metrics that make up core Web Vitals will evolve over time, but the current set focuses on three aspects of the user experience, which are loading, interactivity, and visual stability, which, as you can see here, are largest contentful paint, first input delay, and cumulative layout shift. Now, while the core Web Vitals are the critical metrics for understanding and delivering a great user experience, it's important to note that there are other vital metrics as well outside of the core Web Vitals. So these other web vitals often serve as supplemental metrics for the core web vitals to help capture a larger part of the experience or to aid in diagnosing a specific issue. And to give an idea of how the web vitals work together, you can see a breakdown in this infographic of the various web vitals provided by Lighthouse. So here we can see the optimization score broken down by the weight of each component, where you can see LCP is 25%, and then TBT, which is the lab equivalent of first input delay, is 25%, and CLS is 5%. So while they say the weights may be revised in later versions, this gives you an idea as to what to focus on. So next slide, please. So now let's get into the 3 core web vitals. The first here being largest contentful paint. So this measures when the largest content element in the viewport becomes visible, so it can be used to determine when the main content of the page has finished rendering on the screen, such as the hero image on a homepage. So one factor contributing to a poor user experience is how long it takes a user to see any content rendered to the screen. So that is what LCP is addressing here. Next slide, please. And the next would be first input delay. So this captures a user's first impression of a site's interactivity and responsiveness. It measures the time from when a user first interacts with a page to the time when the browser is actually able to respond to that interaction. So for example, when you first load a page and you click a button, but nothing happens as the JavaScript is still executing. So this can be quite a frustrating experience. So although largest contentful paint measures the time it takes for content to visually render or paint on a page, it does not capture load responsiveness or how quickly a page responds to user interaction like first input delay does. Next slide, please. So here we have cumulative layout shift. So this measures the instability of content by summing shift scores across layout shifts that don't occur within 500 milliseconds of user input. It looks at how much visible content shifted in the viewport, as well as the distance of the elements impacted and how they were shifted, excuse me. As layout shifts can be very distracting to your users, you of course want to avoid this. So imagine you've started reading an article when all of a sudden elements shift around the page. That will essentially throw you off and require you to find your place again. So this can be caused when visible elements are forced to move because another element was suddenly added to the page or resized, leading to a very frustrating experience for your users. Next slide, please. So now that you've learned about the core web vitals and what they are, let's talk about how to measure these metrics. Next slide, please. So let's talk about Lighthouse. So Lighthouse is an open source automated tool for improving the quality of web pages. You can run it against any web page, whether it's public or requiring authentication. Lighthouse audits for performance, accessibility, progressive web apps, SEO, and more. You can run Lighthouse in Chrome DevTools from the command line or as a node module. You just have to give Lighthouse a URL to audit, and then it will run a series of audits against the page, and in turn generates a report on how well the page did. So from there, you can use the failing audits as indicators on how to improve the page. As you can see in this screenshot, this site is scoring in the green zone, which is where you want to be ideally, but for any time you're not in the green, Lighthouse will give you actionable advice as to what you can do to help increase your score. And you'll see what this looks like shortly. Next slide, please. The next tool is Webpage Test. So Webpage Test is a web performance tool that uses real browsers to access web pages and collect timing metrics. By entering all of the relevant information you see here in the screen, you can test your user's real experience with global locations, devices, and browser versions. So this allows you to correlate your user's visual experience to the technical measurements of your site. Now, just like Lighthouse, you will get to see what Webpage Test looks like in action shortly. Next slide, please. So now that we've discussed core web vitals and how to measure these statistics, let's talk about what you should take into consideration to either keep or place your scores in the green zone. Next slide, please. So the first thing you can do is deliver optimized assets. Delivering optimized assets is one of the best ways to affect your web performance and let you deliver positive experiences to your users. Now, this may seem like a no-brainer, but when you think about delivering an optimized asset, what does that mean? So let's take a look. Next slide, please. So let's first talk about formats. Asset formats can significantly affect page load time and bandwidth, and in turn directly affect user experience. So modern formats like WebP can reduce image sizes by 30%, naturally leading to faster page loads, more site engagement, and higher conversion rates. Taking a look at the three image formats, you can see that converting the original JPEG into a WebP already gets you a 26% savings, and converting it to AVIF gets you a whopping 61% in savings, showing just how valuable it is to serve optimal asset formats. Now, keep in mind that this, of course, is all easier said than done. A common developer task is to pick the optimal formats for various scenarios based on the content and the viewer device or browser. So for example, JPEG for captured photos or for faster loading, and PNG for illustrations or pictures with a transparent background. And for Chrome, Safari, IE, and Edge browsers, you must take into account additional logic for modern formats like WebP and JPEG XR. So as simple as the requirements for browsers and format compatibility might be, manually computing the format logic for a large volume of assets is complex, likely inefficient, and certainly no easy task. One way to take the pain out of delivering assets in their optimal format at scale is you can easily use features such as an auto format algorithm. Auto format algorithms can look at the requesting browser and content of the asset to determine what the optimal format is and auto convert it on the fly if necessary. So features like this can help you stay ahead of the curve by offering modern formats such as AVIF displayed here. So this not only keeps you up to date, but also requires less maintenance on your end. Next slide, please. Now let's take a look at quality. So a common concern for image and video edits is degradation of the visual quality. How can you easily determine just how much to compress the asset without sacrificing any visual quality? Precise adjustment of the compression level, complemented by fine-tuning of the encoding settings, can significantly reduce file size without any noticeable degradation. The hard part here is that no single optimal setting exists because it depends on the compression algorithm and the asset's format and content, indicating that setting a default quality level amongst all your media is pretty suboptimal. So looking at the three different versions here, you can see that all three look quite similar, and the difference here is actually in the file size. Although surely not every image out there will be able to be reduced to a quality level of 20, you can see just how much savings you can have if you have a way to calculate this. So a great way to do this at scale is by utilizing a quality algorithm to help determine how much you can compress the asset without sacrificing any visual degradation. So you can utilize an algorithm to determine the optimal quality by taking into account the content of the asset and just how much you can compress it without the human eye noticing. Next slide, please. So last but not least, we have size. Although it may seem straightforward to deliver assets at the desired size, I'm sure we're all guilty at one point or another of resizing assets on the client side. So we want to avoid doing this at all costs because doing so is a sure way to not only increase load time, but also leads to wasted bandwidth consumption. So this will be discussed later in the workshop, but you'll see there is an opportunity section of your Lighthouse report in which lists all images in your page that aren't appropriately sized, along with the potential savings in kilobytes, as this is an essential best practice. Next slide, please. And the last piece of media best practice advice for today would be to deliver your assets via a content delivery network, more widely known as a CDN. So at its core, a CDN is a network of servers linked together with the goal of delivering content as quickly, cheaply, reliably, and securely as possible. So in order to improve speed and connectivity, a CDN will place servers at the exchange points between different networks. Some popular CDN companies that you may have heard of are Akamai, Fastly, and Cloudflare. So now that you've heard about some media best practices, let's see them in action. Next slide, please.
Cool. Thank you, Marissa. So we saw what are the different ways in which you can get an optimized asset. So that is using format, quality, and size. So what we thought is let's actually make it look real. Let's build it on a page that is somewhat similar to a typical e-commerce site, and then we'll try and optimize it. So let me show you a demo. So let me share my screen. Okay, there we go. So this is like a typical e-commerce landing page. So you have a big product image, some explanation about it, and then a few other explanations. So this is a page. Now what we are going to do is try and see what is the performance looking like for this page using the tools that we just mentioned. Then we'll see what are the recommendations we get, and then we'll actually take action on a few of them. So the tool that we are going to use, like Marissa mentioned, is Webpage Test. And what I like about this tool is within Webpage Test, if you give your URL and so on, and then you have this tab called Chromium. So if you go in there, you have an option to capture the Lighthouse scores. So you can actually do two different things. You can actually run as if it's a desktop. So that's what I have got here. I'm saying it's Chrome. But when you run it as a Lighthouse, it is actually going to run it as a 3G fast, and it's going to be like a typical Motorola kind of a device. And I think there's something wrong with the display. Yeah, now we are back. So yeah, this is what we will get, right? So this is a typical web page test. So let's see what happens when we run it to our baseline page. Now, don't worry, we are going to share the slides, and that'll have links to everything that we are showing here. And here is what we get for the baseline on this page. It just shows that the largest contentful paint, if it was a desktop device, it's about 1.9 seconds. Whereas when Lighthouse runs the same test, it is saying that the LCP score is now 4.99 seconds. Not only that, it's giving me an overall score of 55. That's the weighted sum of different metrics. And it's giving us a bunch of recommendations on what we can do to make it better. And since we are focusing on media, I guess the second one actually stands out for us, which is serve images in the next gen format. And if you notice there, in this specific site, we had a lot of PNG images. In a realistic site, this would probably be a JPEG. Um, and I have tried this out with even stock photo images from Pexels, and it still comes back with a lot of recommendations around the same set. So that's something that almost always comes out as a recommendation. And apart from that, there is one more, which is properly sizing the images, which is what Marissa was talking of as the last optimization. And then there are a few other things, which is, it says on the image tag, we need to specify the width and height, right? Now, those are all the recommendations. And if you actually scroll down and expand certain things, it'll also tell you what is the element that is actually considered as LCP. Now, this matters because if this is not even an image, no matter what other optimizations we do, it's not going to help on that specific setup. So that's something to keep in mind. So what I did is I took these recommendations and I built out an optimized page. So that's why the URL says optimized. And you will not notice anything here. It's the exact same thing. But if you look at the source, you will start seeing some things to change. So the first thing I have is, well, this is not really related to media, but I did pre-connect for the fonts because there was a lot of delay in loading the web fonts. But apart from that, most optimizations are related to the images. So we have added an F auto Q auto parameter. So that's the auto format and the auto quality. And then for each of these image tags, I've added the width and the height parameter. Now this one, what it is actually going to do is this. So when your browser is parsing the HTML, it has to reserve some space for these images. If you don't specify this, it kind of squishes everything together. And when the image is actually downloaded, it expands. So kind of pushes all your content down. When that happens, you suffer cumulative layout shift, and that's going to be penalized. And it's also kind of very irritating to the users if it happens a lot, right? So that is the fix that we're trying to get through this. So it's the same set of optimization for a bunch of images, but once we kind of go below the fold, you will actually notice something else being added. So the other thing that I've done is this. So I'm saying loading equals lazy. Let me just make it a little more big. So what that does is on Chrome and few of the Chromium-based browsers, you're telling the browser that this image is not going to be rendered on the viewport. So the browser can kind of load it after everything else has been done, or only when it detects a scrolling motion. At that point, the browser can decide and load this image. So that's lazy loading for you. And the other one, decoding async. Now, this is actually a very recent addition. What this is telling your browser is go ahead, download the bytes of the image, but don't actually spend any CPU cycles in trying to understand this and render and rasterizing and rendering the image. So basically, you're telling that we want to play nice, get the image, don't do anything, finish all the parsing of JavaScripts or style sheets and so on. And once you're done, come back and actually rasterize and render the image. So that is this specific tag. When I made this change, I didn't notice a huge difference in performance, but on Webpage Test, I did notice a slight improvement on CPU utilization. So for this page, it didn't matter, but for others, I guess there may be a benefit to it. So with all of these changes, what did we get? So, the first thing, of course, is to run the baseline comparison. So this was a baseline, and here we noticed it's 1.9 seconds on the desktop experience. Here, for the same experience, it has come down to 1.27 seconds, right? That's a pretty decent drop. But in the Lighthouse, if you notice, the score has gone up by 5 points, nothing to write home about. But there is a big difference in the largest contentful paint. It's come down by over 1.5 seconds, right? And if you notice the recommendations now, most of the things related to images are actually gone. There is still one about properly sizing the images. Take this as a homework. So once we share, you can actually try it out for yourself and resize. I just wanted to leave that out there. But all other recommendations are gone, and the JavaScripts are the ones that are causing the most issues. So that's what Google is complaining about. Um, The other good thing about Webpage Test is you can actually compare your tests. So here what I've done is I've got the same baseline and the same optimized test. And if you notice here, you can kind of see what is happening on a per second basis using a film strip view. And if you notice here at 1.6 seconds, this is done with the optimized page. Whereas with the baseline one, it's kind of keeps going on and on. And this is where the font optimization kind of kicked in. So even though the content is there, it's all in the base page, it doesn't show up because the font did not load. So that is the reason I made that small change there. But apart from that, if you notice, the images actually load much faster. And this is also indicated by the visual progress. Now this one tells you how quickly your browser goes to finish line. And with the optimized, it jumps from nothing to almost 85%, well, 85%, and then immediately jumps very close to 100%. Whereas with the unoptimized version, it keeps staying, well below 10% for a long time, and then kind of jumps and everything is done at once. So that is how we were able to optimize the site. So that's basically what I wanted to show in the demo. So let's jump back to the slides. Okay. Now, yeah, we already saw all of this. So, you can take a look when you get the slides. Can you go to the next one, please? Next slide. Next slide. Next slide, please. Next one. Next one, please. Yeah. So this basically summarizes all the optimizations that I spoke of. So we definitely added the F auto Q auto parameter. We added the width and height. We saw loading equals lazy. And I've just given details on where we found this optimization on decoding equals async. And you can also try resizing by display dimension. So that's something you can try later on. Can you go to the next slide, please? Okay, and this one just gives you direct links if you want to take a look at all the things that we just showed in the talk today. Can you go to the next slide, please? Okay, I think you'll have to click next few times. There's an animation there. Can you just go next? next. And next again, please. Yeah, thank you. So we saw what Core Web Vital is and how important it is. And then we also saw some of the tools that can help you measure the Web Vitals, using Lighthouse audits and Webpage Test. And then we finally walked you through the actual workflow of measuring, getting a baseline, looking at the recommendations, and actually making those changes. But that is not the end of everything. So can you go to the next slide, please? Yeah, we did not cover a whole lot of things. As Marisa said, there are a lot of pain points, but this specific set gives you a little bit benefit. And if you have been following all the talks, the person from apartment therapy, he actually said how they used F auto, Q auto as one of the more important things for getting a better LCP score. So we kind of wanted to focus around the same talk track. But then there are a lot more things we can do. And if you want to understand all of this, you can take a look at these references. And if you can go to the next slide, please. We do have a bunch of training as well on the way we can optimize. So those are the links that we have here. And if you can go to the next slide. And if you really want to nerd out and go in and understand how each calculation is done, or what is the meaning and what are the different corner cases with these measurements, you can take a look at all of these documentations. So that's all we had. Can you go to the next slide, please? And yeah, that's basically what we had, and we are open for questions.
So I do see that we have a question here. So regarding Core Web Vitals, what are things companies should consider when working on their performance budget? I don't have a lot of time to answer this. I'm going to try and answer as quickly as possible. So some things that you can do is, one, try to reduce JavaScript execution. So just as I was talking about with first input delay, if you see that you're scoring low on that, it means that your page interacts with users typically over 300 milliseconds. So I would definitely pay attention to JavaScript execution. Next would be to implement lazy loading, as Akshay had kind of showed just a few minutes ago, as that's going to help with only loading assets that are in the viewport. You want to, of course, optimize and compress your images, as we've definitely tried to emphasize that today. And then you would want to provide proper dimensions for images and embeds, as we talked about specifying the size of your assets so that they don't get resized on the client side, make things shift. That can affect your Core Web Vitals in multiple ways. And then, of course, you want to try and improve your server response time. So that's where kind of using a CDN would really come into play, with being able to load your assets quickly. Do you have anything to add to that, Akshay?
No, I think that itself will be a whole talk track.
Yes.
We're kind of out of time.
Yes. So if you guys have any more questions and want to reach out to us, please feel free to reach out to us on LinkedIn. We're more than happy to answer your questions. And yeah, I hope you guys enjoyed our talk today. Thank you so much.
Thank you.
Bye.